All right, so let's take a look at problem number 15. This is a absolute value problem, and so we want to try to isolate what's in the absolute value right here. So the first way to do that is if I add 5, that will get rid of this negative 5 here. But of course I can't add 5 to just one side, I have to add it to both sides. So when I do, those cancel and I'm left with 4 times the absolute value of negative 2 plus 2r is equal to 3 plus 5 is 8. And now again, I want to isolate what's in this absolute value right here. So I can do so by dividing both sides by 4. If I divide by 4, then this cancels. So I divide both sides by 4, and I have the absolute value of negative 2 plus 2r. That's going to be equal to 8 over 4 is 2. So now, if the absolute value, if this thing here is equal to 2, then the thing that's inside it, negative 2 plus 2r, that can be equal to negative 2 plus 2r. That can be equal to 2, because if this whole thing inside here is equal to 2, then the absolute value is going to make it 2. Or this thing inside there, negative 2 plus 2r, could also be equal to negative 2. Because if it's equal to negative 2, then if this thing in there is negative 2, then the absolute value makes it positive 2, which is what we're looking for. So it can be equal to either 2 or negative 2. So now we just have to solve these. So we have negative 2 plus 2r equals 2, or negative 2 plus 2r equals negative 2. All right, so to solve this one, if I add 2, then I'm going to isolate the 2r over here. But if I do it to one side, I have to do it to both sides. I'm going to have 2r equals 4. So if I divide by 2 to isolate my r, the 2's cancel. Oops, sorry, it's divided by 2. Sorry about that. Divide by 2. So now I have r equals 4 over 2 is 2. So r could equal 2. But also, if I add 2 here, and then if I add 2 to one side, I have to add 2 to both sides. By adding 2, that cancels, and I'm left with 2r equals negative 2 plus 2 is 0. So now if I divide both sides by 2, I end up with r equals 0. So my answer is going to be that r equals 2 or 0. Either of those will work for the absolute value problem we have here for number 15. All right, so problem number 16 is asking us about a mixture. So I'm going to draw a matrix to make my life easier here. 1, 2, 1, 2, 3, 4, and 1, 2, 3. Okay, so like that. Okay, because what I know is that the volume of something times the percentage is going to equal the what I'll call pure. What is the 100% of whatever it is? So it's like pure acid or whatever. Okay, so this first part here is we have 12 gallons of a 45% acid solution. So we've got 12 gallons of a 45% acid solution. And that was mixed with 3 gallons of pure water. So that would be 3 gallons of pure water is 0% acid solution. So now we have to try to find out, well, what is the concentration of the mixture? So we have to do some calculations here. So the first thing we have to do is figure out, well, how much acid is in the first one? How much acid, if we looked at the first one here, how much is in it? So if I were to take 12 gallons and I multiply by 45%, I end up with that first thing is 5.4 gallons. It's the same thing as 5.4 gallons of pure acid. The second one, if I multiply 3 gallons times 0, that's the same thing as 0 gallons of pure acid. And so now we have the mixture. The mixture is the one that's going to be right here. Well, if I take 12 gallons of something and add it to 3 gallons of something, I'm going to end up with 15 gallons of something. And within that 15 gallons, we have 5.4 gallons of pure acid plus 0 is just going to be 5.4 gallons. And so the percentage, if it's going to be, so if I call this X, I'm going to say 15 gallons times X equals 5.4 gallons. If I divide both sides by 15 gallons, then the 15 gallons is going to cancel over here. I've got X over here. I've got the gallons are going to cancel. I'm just left with 5.4 over 15. And if I calculate that out, 5.4 over 15, that's going to equal 36%. Or it's going to equal 0.36, which of course is equal to 36%. So that is going to be my answer. That what is the concentration of this new mixture right here? Well, that would be 36%, because we calculated that out using that right here, using it out. So this is going to be 36%, and that's what we're looking for. Number 17 is a mixture problem. It's asking us about metals containing iron. So if it's a mixture problem, I'm going to create a matrix here. Okay, and once again, what do I know? I know that my in this case it is weight. So we know that our weight times the percentage is going to equal the pure weight. So in this case, the weight of iron. Okay, and so what do we have? Well, we have a metal containing 70% iron. So we have a metal containing 70% iron, and how many pounds of it? Well, that's what it's asking, how many pounds. So I'm going to say that's X pounds of a weight of a 70% something 70% iron, okay, must be combined with 7 pounds of a metal containing 20% iron. To form an that's not ally, excuse me, an alloy of 35% iron. And so we're trying to find X here. And so now we can add and multiply. If we have X pounds added to 7 pounds, that's going to be 7 plus X pounds. If we have X pounds times a 70% solution, or 70% of iron, that's going to be 0.7x if I just multiply over. And 7 pounds times 20%, that's going to be 1.4 pounds. And so if I add these together here, I'm going to have 1.4 plus 0.7x. So now I can use that to help me solve this one. What do I know? Okay. Oh, because I know here that if I add them, I got this way. If I multiply this way, right? So if I add these this way, it's 1.4 plus 7x. If I multiply this way, I'm going to have 7 plus x, so 7 plus x times 35%. So 35% times 7 is equal to 2.45. And if I distribute, so I've got 2.45 plus 0.35x. And so if I add them this way from here to here, I get this. And if I multiply here to here and get this, I know that this thing here and this thing here must be equal. They're equivalent. They're the amount of pure weight we have. So in my equation, I would know that 1.4 plus 0.7x is going to equal 2.45 plus 0.35x. So now I can solve for x. So I want my x's on one side of the equation. So if I subtract 0.35x, that's going to cancel here. But of course, I can't do it to just one side. I have to do it to both sides. So that would give me 1.4 plus 0.35x equals 2.45. Now if I subtract 1.4, and I do that obviously to both sides, not just one, that cancels, and I'm left with 0.35x would equal 1.05. I want to isolate x, so if I divide by 0.35 and do the same thing here, 0.35, that gets me x equals 3. So how many pounds of metal containing 70% iron? Well, the answer would be right here, and that would be 3 pounds. So if I take 3 pounds of 70% solution, or 3 pounds of 70% iron, and mix that with 7 pounds of 20% iron, I would end up with 7 plus 3, 10 pounds of 35% iron. So for problem number 18, this is a distance problem, or a rate times time equals distance. So if I were to create a matrix here, okay, I know that rate times time equals distance. And for this one, we have a cattle train and a passenger train. So we have a cattle train. So I'll make my box one thing bigger here. This is the train. Okay, so this one is going to be the cattle train. And the blue one, I'll make the passenger train blue. Passenger, okay. So what we know is that they leave at the same time, and we know that they leave at the same time, and that they're going in opposite directions. Okay, so the rate, the passenger train traveled 7 kilometers an hour faster than the cattle train. So we don't know what the cattle train's rate is. That's what we're trying to find. Find the cattle train's rate speed. So we'll make that x, which means the passenger train is 7 kilometers an hour faster. So that would just be x plus 7. The time, we don't know what the time is. Oh, after 7 hours, excuse me, we do know what the time is, excuse me. We know that they went 7 hours, and they both went 7 hours, because they left at the same time. Then what we know is that the distance of the cattle train is the rate times time, so x times 7 would just be 7x. And the distance of the passenger train is 7 times 7 plus x. So if I distribute the 7 times the x equals 7x, and 7 times 7 equals 49. And it tells us here that after 7 hours, they're 217 kilometers apart. So we know that this and this together that 7x, the distance of the cattle train, we know that the distance of the cattle train, 7x, if we add that to the distance of the passenger train, which is 7x plus 49, when we put those together, they are 217 apart. So 217. So now we can combine our like terms. We have a 7x and another 7x. That's 14x plus 49 equals 217. If I were to subtract 49 from both sides, I end up with 14x equals, so that'll be 150, they go to 8, 168. And then if I divide both sides by 14, get my x equals, that would be 12. So what is the cattle train's rate? The cattle train's rate is 12 kilometers per hour. So kilometers per hour. That is the rate of the cattle train. All right, so question 19 is a distance problem. So I know that rate times time equals distance. So I'm going to draw a box here. Okay, and I've got two people. And I know that their rate times the time equals distance. And I've got two people. The first one is Rob. Rob left the hardware store and traveled north. And I've got Jenny. So let's put Rob in here. That's Rob. And I also have Jenny. Jenny left 2 hours later, traveling 18 kilometers an hour faster in an effort to catch up with him. After 3 hours, Jenny finally caught up. Okay, so Jenny went 3 hours, and if she went 2 hours after Rob, then Rob is the 2 hours waiting plus Jenny's 3 would equal 5. So we know Rob went 5 hours and Jenny went 3 hours. Okay, well, what is Rob's average speed? That's what it's asking us. What is his average speed? We don't know. We'll call that x. And what is Jenny's speed? Well, Jenny's speed, we know, is 18 kilometers an hour faster. So whatever Rob's speed was, Jenny's is that plus 18. And we also know that, of course, if Rob went x for 5 hours, his distance is 5x. And we know that Jenny, if she went, her speed is x plus 18, and she went 3 hours, and if we distribute 3 times x is 3x, and 3 times 18 would be 54. And then finally, we know that she caught up to him. So if she caught up to him, they've gone the same distance. So Rob's distance of 5x must be equal to Jenny's distance of 3x plus 54. So, in other words, if I simply, to solve for x, if I subtract 3x from both sides, I end up with, those cancel, 2x on the left equals 54. If I divide by 2 on both sides, I end up that x equals 27. So what we know is that the final answer, what is Rob's speed? Rob's speed would be 27 kilometers per hour. All right, so number 20 is a work problem. So I'm going to draw a box. And in this matrix, I've got some people, and then I know that the rate that they work times the time is going to be the total work. So we've got people, we've got the rate that they work, got the time that they work, and then the rate times the time is going to equal the work done. Okay, so what we know is that we have JD. Okay, and JD takes 9 hours to tar a roof. So the roof, we're just going to call the work done one roof. So we'll just call that 1. And we know that Ashley can do the same roof in 12 hours. So it takes JD 9 hours, and Ashley, it takes 12 hours to do that same roof. Well, if they work together, how long would it take them? So if they work together, how long would it take them? So together. Okay, well, we know that together they're going to still do the same roof. And now we have to figure out the rate. So if rate times time equals the work done, then if I call this J for JD's rate, then J times 9 equals 1. If I divide by 9 on both sides, I get that J equals 1/9, which makes sense. If JD can do a roof in 9 hours, then every hour JD does 1/9 of a roof. For the same reason, the same calculation, Ashley does 1/12 of a roof every hour. Okay? So their rate together would be, if I add these two together, that would be the rate. So what is 1/9 plus 1/12? Okay, well, I can rewrite these as 1/9. I could write as 1/3 times 3, and 1/12 I could write as 1/3 times 4. So they both have a 3 in them. So if I end up multiplying this one by 4/4 and this one by 3/3, I should be able to get this common denominator. So if I do that, on the top for this one, I'm going to get 4, and on the bottom I've got 9 times 4, which is 36. For this one, I'm going to add those up. I get 3, multiply it out, 36. Okay, so when I add these up, I get 7/36. So together, they can do the work, or together their rate is 7/36. They can do 7/36 of a roof in 1 hour. So what's the time? That's what it's asking us. How long would it take? If I call that x, then what I know is that 7/36 times x equals 1. If I multiply by the reciprocal, 36/7, and do that to both sides, obviously, have to, through balance, do the same thing to both sides. The 7's cancel, the 36's cancel, and I'm left with x equals 36/7. And since the problem says to round to the nearest hundredth, if I just take out what is 36 divided by 7, 36 divided by 7 is going to equal, that's going to be about equal to 5.1428, and rounding to the nearest 100th, that would be equal to 5.14 hours. So if JD can do a roof in 9 hours and Ashley can do a roof in 12 hours, then together they should be able to do the roof in 5.14 hours. All right, looking at problem number 21, this is a work problem. So I'm going to draw a matrix to make my life easier here. And I'm going to have some people who are doing work at a certain rate. And if you multiply that times the time that they're doing the work, that's going to be equal to the work done. Okay, so we've got two different people here. We've got Emily and we have Julia. And they work together. Okay. So working together, Emily and Julia can dig a 10-foot by 10-foot hole. We'll call a 10-foot by 10-foot hole just one amount of work done. That's what 10-foot by 10-foot hole means. Okay, they can do it in 4.24 hours. Now, had she done the work alone, Julia could have done it in 9 hours. So if Julia had done it, she could have done that same amount of work in 9 hours. The question is, how long would it take for Julia to do that work, the same amount of work? Okay, well, the first thing we have to do is figure out what the rates are, right? So this one is, if it's the rate times time equals distance, then the rate is just going to be 1 over 4.24. And for Julia, her rate is going to be just 1/9. And Emily, her rate is going to be 1 over x. And so we know that if we add Emily and Julia's rate together, we're going to get the rate we have, what we'd have together. So if I take 1 over x, and if I were to add that to 1/9, I would get the rate that they are together, which is 1 over 4.24. Okay, so to solve this, the first thing I want to do is try to isolate my x. So if I subtract 1/9 from both sides, I would get 1 over x equals 1 over 4.24 minus 1/9. Now I want x alone. I have 1 over x. So what I'm going to do is, if I multiply both sides by x, those x's cancel and I'm left with 1. And on this side I have x times 1 over 4.24 minus 1/9. So if I take this whole thing and divide by 1 over 4.24 minus 1/9, then this whole thing cancels, and on this side I have 1 over 4.24 minus 1/9. Okay, so now I know what x is. I just have to put it into a calculator to calculate the whole thing. So if I take 1 over 1.24, or 1 divided by 4.24, I take that, and then I subtract out 1/9. And then I take the reciprocal of that, because I don't want, I have to take the reciprocal of that. I end up with that together it would take them 8.0168 hours, which if I want to round to the nearest 100th, that would be about equal to 8.02 hours. So if Julia can do it in 9 hours. And together it takes them 2.24 hours, then Emily should be able to do it in 8.02 hours, just a little over 8 hours. Her 8 hours plus Julia's 9 hours doing it together, they can do it in 4.24. Okay, let's take a look at 29. 29 is an inequality. 175 is greater than or equal to negative 5 minus 10p. Okay. Well, just like an equation, I'm trying to isolate my p, so I'm first going to isolate the negative 10p. So to do that, I'm going to add 5, and if I add 5 to one side, I have to do it to both. So I have 180 is greater than or equal to negative 10p. Now I have to isolate the p. So I have negative 10 times that, so I'm going to divide by negative 10. And if I do that to one side, I have to do that to both sides. So the negative 10s cancel. On this side, I have p. On this side, I have a positive divided by a negative is a negative. 180 divided by 10 is 18. And because we divided by a negative, my greater than or equal to sign turns into a less than or equal to sign. So I have negative 18 is less than or equal to p, which is the same thing. I could put the p over here and the negative 18 over here, and the p is bigger on this side, right? The alligator is eating the p. The p is the bigger side over here. So I do the same thing here. It makes it bigger here. So the same thing, negative 18 is less than or equal to p is the same thing as p is greater than or equal to negative 18. So I go to negative 18, and it's greater than or equal to. So equal to, so I fill in that because negative 18 is a solution, and it's all the numbers that are greater than that. All right, so for number 35, we have 2 times the absolute value, m minus 3. Take that whole thing plus 10, and that's less than 32. So the first thing I want to do is to isolate my absolute value piece right here. So to do that, I'm going to subtract 10 so that these cancel, but of course if I subtract 10 from one side, I have to do it from both. So I end up with, on the left, 2 times the absolute value, m minus 3, and that's going to be less than 32 minus 10 is 22. Now again, I want to isolate the absolute value, and I have 2 times that. So the opposite of times 2 is to divide by 2. And I'm left with the absolute value of m minus 3 is less than 22 divided by 2 is 11. So remember, we have less than and greater than. So this is less than, so this is going to be an and problem. So what we know is that m minus 3 is less than 11, less than, so and the negative of m minus 3 is less than 11. Sorry, my bad. So we can solve both of these. M minus 3 is less than 11, and distribute my negative. Negative times m would be negative m. Negative times negative 3 is plus 3 is less than 11. If I add 3 to this one, add 3 to both, I end up with m is less than 14. And if I subtract 3 and subtract 3, I end up with negative m. Those cancel, is less than 8. And so if I have negative m, if I multiply by negative 1, if I do that to one side, I have to do it to both. Negative times a negative becomes a positive. A negative times a positive becomes a negative. And because I multiplied by a negative, I flip my sign. So I have that m is less than 14. So that would be here. I'm going to make that open because it's not less than or equal to, and it's going this way. And m is greater than negative 8. So if I go up to negative 8 and go here, and so if I want the ones that are all the ones that are both less than here and greater than here together, that would be all the ones that are in between.